So chapter 27 is inference for regression. So what we're going to see here is running a hypothesis test to see if there is a linear association between two variables. Thinking back to what we did with the regression equation before, we looked at r squared, and the scatter plot and kind of just made an eyeball judgment if there was a linear association or not. This is going to run more through a statistical test to justify if there is a linear relationship. So we're going to be looking at the null alternative. We're going to be looking at the p-value and using that to make our judgment if there's a linear association. Your setup's going to be the same. Your calculations are going to be very similar. Your conclusion's going to be very similar. The confidence interval that we have to look at is going to be the slope confidence interval for a slope, just judging how much of an increase or decrease there is in our relationship. There's also going to be one extra optional topics that you guys can look at if you're motivated enough. But the three videos, the first three videos that I'm going to have here are going to be needed for the grade assignment for this week for chapter 27. So going through this first video, we're going to look at the null and alternate and the conditions you're going to need to run your hypothesis test. So the first thing we're going to go over some of the symbols that we had before from Unit 3. Okay, this was our regression equation. Remember, the B0 is our y-intercept. The B1 is our slope. We have our y hat, which is our predicted value, and our x is our input variable that we would put in to make our prediction. These are the sample symbols, B1, B0. If we are talking about the parameter, okay, we're going to be using beta. Beta 0, beta 1. We have our mu symbol y, which is the predicted value, and our x. These are the parameter symbols, and these are the symbols that are going to be in your null and alternate. The B1 is going to be what's in our null and alternate, because what we're going to be testing is to see if there's a linear association, if there is a slope. If your slope is 0, that means that we have a horizontal line, which there is no point of plugging in a value of x because every x value will give you the same y value. So what this test is going to run to see if there is a slope other than 0. For most of our null and alternates, we're going to be looking at not equal to. And sometimes you can judge if you are being specific on if there is an increase or a decrease, but for our course we're going to focus on the not equal to sign. The other thing that we talked about in Unit 3 is the residual. This is the difference from our predicted and the observed value. So here we have the symbol for residual, and then y minus predicted, or y minus y hat, which is the predicted y once we plug it into the model. Just a quick subtraction gives us our residual value. Okay, so the important thing to take from this slide, we have our sample symbols, we have our population symbols for the parameter, residual, we have our symbol for the residual, the subtraction, a couple other values that you need to know. Okay, we have epsilon, which is the residual standard deviation. That's going to be given to you when we do our calculation for the test statistic. Okay, if you do want to have the formula, there it is. Okay, we have our SX and our X bar. Those are both just the normal standard deviation and the mean for the X values. Again, they're going to be used in some of the confidence intervals that we calculate. And this is just looking at just our X list, just our X list for our data sets. So that would just be the normal one variable stat to get our standard deviation and our mean. T is going to be our test statistic, also called the T ratio. So we're going to be using the T distribution again. Okay. Here's the actual formula. It is the sample slope minus 0 is what we're going to be calculating. We want to see how far away our sample slope is from 0. Divided by our standard error of B1. So this is the technical formula for the test statistic. Again, we are most likely going to be using the calculator function to do that, but it wouldn't be bad to see, again, we're looking at a difference from our slope to 0, because 0 slope is a horizontal line, which means you can't make predictions. Now, the standard error of our slope. Okay, this formula can get a little ugly. We have our standard deviation for our residual. We have our standard deviation for x, and our square root of n minus 1, sample size of n, that's how many pairs of data we have in our data set. A little simplified version would just be our slope divided by our test statistic. This is the formula I would like you to star. This is one what we're going to need for our confidence interval for our slope. Yes, again, you can do this formula. You should get the same values, but this one's just a little smaller with just a quick division. Slope divided by the test statistic, and that gives us our standard error for slope. Now, for our null and alternate, I'm going to ask that you write out your null and alternate in both equation and as a sentence. Okay, so you don't really need to define the parameter, but you need to state what the null and alternate are telling us or what they are stating. So for our null, we have beta 1 equals 0. As long as you have beta, the 1 it does show it's a slope, but as long as you have beta, I'd be happy with that. And our null is saying that there is no linear relationship, no linear association between the anxiety level and the math test. So this would be the null for the same example that we did for review last week. So we're looking at the math scores and the test anxiety. And again, it's always going to be equal for the null. For the alternative, we have beta does not equal 0, meaning there is some kind of slope. Positive, negative, we're not going to be judging that. But we do see that there is some kind of slope because it does not equal 0. There is a linear association between anxiety level and the math test scores. Make sure you are stating what the two variables are. That's stating the context of the problem. So that would help you just making sure you have context in your answer then. The null is that there's no linear association. The alternate is that there is a linear association. Okay, don't get too fancy. You don't need to write too much. I just need to hear linear or not linear and state the two variables. You need both as an expression equation and also in words for full credit in this for this one. For the conditions, okay, we're not just looking at the scatter plot and R squared this time. We're also going to be going into the residual a little more and also to see if it's a normal population. Okay, so the first one we're looking at is the straight enough. For the straight enough equation, for the straight enough condition, you are looking at just the original scatter plot. Okay, so there's my original scatter plot. And I'm looking at the original scatter plot. There's no bends. There's one possible outlier. It's approximately linear. You're basically eyeballing to see that there's no bends, there's no curves, and no extreme outliers. We talked about this one in the review where there was a little outlier. Not enough for us to say that it's going to affect the validity of our test. The next two, we have our independent assumption and our equal variance assumption. These two are both going to be looking at our residual plot. Okay, so our residual plot should look something like that. For the independent assumption, you're looking for a pattern. A lot of times you can just kind of assume that the linear assumption, as long as one data point does not affect any other data point, there would be independence. So a lot of times this is going to be an assumption that we just assume is satisfied unless you see a pattern in the residual. For this one, we're looking at students' test scores. I'm going to assume students are not cheating. I'm going to assume whatever score one person gets, they will not affect the score of another person. So here we look at X versus the residual and no pattern, and there's no reason to think one student affected another student's score. So that condition is now satisfied. For the equal variance assumption, okay, we're still looking at the X versus residual, but this time we're looking for just a constant spread across that horizontal line that they show. I have here that there's no fan. We're not looking for everything close together and spreading out, maybe slightly, because there's more points over here, but there's no obvious fan where it comes in very tight and then spreads out. It also could go the other way. If it's spread out in the beginning and then gets tighter, that could be an issue as well. In this case, I don't see any real issue, so I would say the equal variance assumption is also satisfied. And the last graph we need to look at is the normal population. Normal population is going to be looking at the histogram for the residual. Okay, so for this one, I'm going to have to change it to a histogram, look at my residual data set, and you're looking for a normal curve. Okay, now for this one, there's 1 point, so we do have 1 point here, which is good, and it's approximately symmetric. You might want to say it's slightly skewed to the left. As for all of our conditions, when we looked at scatter plots and such, it has to be very, very, very off for us not to finish our test. So you really have to have a huge bend in the original scatter plot. You're going to have a very obvious pattern in the residual for us not to move on. If you're looking at the histogram, it has to be very, very, very skewed left or right for us to stop this test. Okay, so for each one, you're like making a quick observation. Okay, so I'm going to quickly show you how to find those three, just a quick review of how to find those three graphs on your calculator. So if I'm calling up my calculator here, first thing you want to make sure you have the data plugged in. I'm looking at L1 and L2. Okay, so those are plugged in. Double check that they're plugged in correctly. The first thing I would do, I would call up just a regular linear model. What this is going to do, I'm going to go down to number 8, LinReg. What this is going to do is calculate the residual for you. Remember, this has to be done first because the residual is calculated for you, and without doing this, the residual, whatever the last calculation you did, that residual is in that list. So you want to do this once quickly, L1, L2, go down to calculate, and now that it has my linear regression equation, R and R squared, I'm not going to jot any of those down now, but now I know my residuals locked into my calculator. So now I'm going to go turn on a scatter plot. I want my scatter plot highlighted. First, I'm going to do just the original scatter plot. So I have L1, L2, zoom 9, and there's my original scatter plot. Okay, I have that. I'm going to make a quick sketch of it, and I can comment on it for the first condition. The second condition was we were looking at independence and equal variance. So now I'm going to be looking at the residual. So the X is still going to be L1, which is our anxiety, but now I want to go to second list, and number 9, some of you guys might have to scroll down a little bit, that is my residual list. That is what was just calculated using the LinReg. So now I'm going to do my anxiety versus my residual, zoom 9, and there's my residual plot. Okay, it's fairly even going across. There's no fan. Okay, we do have that one outlier again, but nothing extreme. I would jot that down, and now I can use that for condition numbers 2 and 3. Number 4 was for the normal population. So going in here one more time, I'm going to go to my plot. This time I want a histogram. So I'm highlighting my histogram, second list, and I'm doing the residual. So again, I have to make sure I'm doing the histogram for the residual plot. I'm looking for a symmetrical histogram. So I hit zoom 9, and there's my histogram, which I can see there is one peak, slightly skewed to the left. Nothing big enough for me to say I can't run this test and it's not valid. I'll state this now. On my answer key, I did not put every single graph. The purpose was to save some paper. Usually I print these out for you. So you're going to want to call those up. On the grade assignment, you will be asked to jot these graphs down. A quick sketch to show what it is looking at. And if everyone's using zoom 9, if your list is plugged in correctly, everyone's graph should look exactly the same. Okay, so you will be asked to do that for a grade assignment, is to jot down these pictures. Kind of like I had for the PowerPoint that we just looked at. Okay, all 3 graphs were shown, so that is your justification for the conditions. Okay, so there's the first 2 parts of the test, your null and alternate and your conditions. Okay, the next video shows the calculations on the calculator and the conclusion that you should come up with for your test.